Good morning to all. I'm Sumitra, Associate Professor in Triple Department of R&D Engineering College. I'm handling design of electrical apparatus this semester. So I'm going to discuss about the Unit 1 under the subject Design of Electrical Apparatus. So considering Unit 1, it is going to deal with design of field system and armature. So what all the topics we are going to cover in this unit is, first we need to know what all the considerations we have to remember before going for any mission design, and also the materials required for constructing a mission, and also what all the design aspects we need to follow for designing your magnetic circuits, and some basic terminologies involving your magnetic circuits. So let me start with the unit with the basic things. So first, before going for a mission design, we need to know what is the design actually. So design is nothing but a creative and physical realization of theoretical concepts. So this is nothing but a general design. But if you are talking about engineering design, then apart from that general design, it should include some other concepts like application of science, technology, and inventions and all. So we can define our engineering design as an application of science, technology, and invention to produce a mission which has to perform a specific task. So now the next thing is making a mission to perform a task alone is not a good design. A good design must be supposed to satisfy the customer's requirement, as well as it should be economical from the customer point of view also. So final definition may be given for an engineering design in this aspect. Engineering design is an application of science, technology, and invention to produce a mission to perform a specific task, and that too with optimum efficiency and economy. So this is the definition for a engineering design. Okay. So before going, we need to see what are the major considerations required to come out with a good design. Okay. So the major considerations are nothing but the cost, durability, and at the same time, it should compile with the performance criteria as laid down with the given specifications depending upon the customer requirements, right? So, but if you're practically speaking, it is very tough for us to combine all the above said factors, that is, all the above said considerations together to come out with a good design. So, we need to provide a balance between all the three factors such that the mission is going to perform, or a mission is going to balance all the three above factors in a reasonable extent, right? So, that's what here mentioned, and a compromise must be made between the cost and the durability so that both the customers as well as the design people is going to get satisfied with the design of a particular machine. So next, coming to the structure. Before going for design of electrical machine, we need to know what are all the circuits we need to design in order to come out with a machine. For example, if you are going to simply speaking, it is a generator, but lot of things are there inside the generator, right? So it's not that much easy to come out with a it's not that much easy to come out with a design within a few days of a few weeks and all. It will take a lot of effort from the designer point. So first we need to know what all the circuits involved to come out with a complete design. So regarding an electrical machine, the major circuits getting involved in the design of the magnetic circuit, electric circuit, dielectric circuit, and the thermal circuit. So we all know that the magnetic circuit is the one which is responsible for creating a magnetic flux, because magnetic circuits is playing a vital role in any energy conversion principle, right? So we all know that energy can be neither created nor be destroyed, but it can be transferred from one form to another form. So in all the electrical machines, a magnetic circuit part is a vital part. Okay, so first we need to design a magnetic circuit. So it is the one which is used for providing the path for the magnetic flux. And then coming to the electric circuit, so for if you are talking about the generator, the final thing must be, that is, the expected output should be in electrical form. So for that, we need to construct some electrical circuit and all. It may comprise a stator winding or rotor winding or both at the same time. And even if you're talking about a transformer and all, it is required to convert or not convert, transfer the electrical energy from one form to the another form, right? So these are all the things which comes in your electric circuit. Either it can be a conversion circuit or it can be a transference circuit, okay, which deals with the electrical parameters. Next comes your dielectric circuit. So since we have a electrical circuit, magnetic circuit, which is supposed to carry very high values of voltage and some currents, so in order to deal with all those things, definitely we are in need of providing the dielectrics. So that is coming under this dielectric circuit. It majorly comprises of your insulation, which requires to isolate one conducting material from the other. For example, if you're talking about the transformers and insulation between the windings from the core or between the HV and LV windings. Okay, so obviously this is coming under your dielectric circuit. Then talking about thermal circuit, so this circuit is mainly intended to take care of the mode of dissipation of the heat. Since the electric circuit is and the magnetic circuit is carrying current and voltage of higher values of higher voltages, higher levels of magnitude. So obviously it will experience certain heat, right? So that temperature must be exposed in a proper methodology. So that is coming in the thermal circuit. So mainly it is concerned with the mode and the media for dissipation of the heat, which is produced inside the machine in the form of the losses, in account of losses. And last comes your mechanical parts. So as we all know that if it is a rotating machine, definitely some bearings, shaft and some frame parts are subjected to wear and tear. So we need to frequently check all those things, and also we need to provide proper care while designing the mechanical parts, right? So these are all the circuits we have for going to design any electrical machine, whether it is a static machine or a rotating machine. And then coming to the limitations, right? Limitations. Simply we can't go with the design as such. We need to check whether the design of that particular circuit is well within the expected limit. So after designing the entire thing, we can't able to check whether all the things are going to work perfectly or not. So before designing, that is, before completing each and every part, we need to have certain factors as a constraint so that that circuit cannot violate that given levels. For example, if you are going to design a magnetic circuit, so as its objective is to create a flux, we need to consider the saturation level of that core, right? So saturation comes for important constraint or important limitation while designing a magnetic circuits, right? So high values, if you are designing a magnetic circuit with high value of flux density, which means that it requires more excitation current to create a flux, that is to create a magnetic field. So obviously it results in high cost of that field system. And then coming to the temperature is the second constraint or second limitation is the temperature rise, right? Because as we all know that insulation is playing a vital role in both the magnetic and electric circuits. The operating life of the machine depends upon the type of insulating material used, right? So if an insulating material is operated beyond its maximum allowable temperature, then definitely its lifetime is going to be drastically reduced. So we need to provide proper cooling and ventilating techniques so that to keep the temperature rise within the specific limits, right? So that's coming under the second one. And the third one is the insulation. So wherever we have some electrical machines, definitely the insulating materials plays a vital role, as I said earlier. So these insulating materials are supposed to experience some stresses, mechanical stresses, thermal stresses, and electrical stresses. So whatever material we are using for constructing that insulation part should withstand all these stresses produced when the machine is working, right? So we have to take care while using some proper material for considering the insulation purpose. And next one is your efficiency. So efficiency, we all know that a machine is said to be a good one if its efficiency percentage is high. So obviously we have to design a machine with a high value of efficiency as far as possible. So in order to design a high efficient machine, we should design certain values, certain parameters inside the circuit so that the magnetic and electric loadings. So what do you mean by magnetic and electric loading? That I'll be explaining in the later sessions. Right now, you need to know two important loadings which become frequently playing a major role in design is that the magnetic and electric loading. So in order to design a machine with a higher efficiency, it is enough to design the magnetic and electric loadings of very small value so that the efficiency can be achieved at a higher rate. Okay. So the next factor is your mechanical parts. So as we all know that being an electrical machine, that to a rotating machine, wear and tear will be occurring very frequently. So the parts which is comprising under the mechanical circuit must be designed with a utmost care, right? For example, if you are talking about the design of mechanical for induction motors, the length of the air gap must be kept as small as possible, because if that length of air gap is small, then only it should operate. It should supposed to operate with a high power factor, right? So at the same time, the length of the air gap is also affecting the size of the shaft. So most of the mechanical considerations regarding a rotating machine is depending upon size of the shaft, which in turn means which in turn depends on the length of the air gap, right? So the shaft of the induction motor should be short, and at the same time it should be stiff enough so that there is no significant deflection of the shaft, right, due to some unbalanced magnetic field, etc. And next comes a commutation. So as we all know that commutation is a process which requires or which does the rectification from AC to DC. If you're talking about a DC generator, this is playing a major role. So during commutation and all, there is a possibility for getting sparking, right? So while designing, this should not be happening very frequently. Otherwise, it will deteriorate the life of the brushes and whatever things present in getting involved in the commutation process, right? So that's what here it is mentioned. The problem of commutation is important in case of commutator machines. That commutation condition limit the maximum output that can be taken from a machine. Okay, so we need to provide utmost care while designing the commutation circuit. Then comes the power factor. As I mentioned already, for induction motors, it is advisable to design the length of the air gap to a smaller value so that the machine can work with a higher power factor. Why we not supposed to operate the machines with the lower values of power factor is that in case if it is operating with the lower power factor, for handling the same power, you need to go with the larger conductor size for carrying that current, right? So hence it is not advisable for us to operate any machine with the poor power factors, since it results in what to say, the cost increase, and at the same time the efficiency is also drastically getting decreased because of the various power losses, right? So it is always advisable to operate any electrical machine with a improved power factor so that we can go with some external or auxiliary devices for improving the power factor in case of even induction motors also. Okay, then at last, consumer specification and standard specifications. So whatever may be the design, it is supposed to satisfy both the consumer specification. At the same time, the design must be satisfied by the standard specification. There should not be any violation in the specifications given formulated by the government, right? So it should satisfy both the consumer specification and the standard specification. So in the next session, I will explain about the different types of engineering materials required for constructing an electric